Before we say anything, look at this chart. This chart destroys the idea that overall vibration levels mean anything for diagnostics. Now listen carefully. Across all machinery types, early-stage faults cause an increase in overall vibration levels in only about 10 to 15% of cases. Spectral and phase analysis detect 100% of early-stage faults. This is the core message. Keep this chart in your mind, everything else in this video flows from it. Let's start. Imagine going to a mechanic and telling him,
"The overall vibration on this pump is high. The international norms say it's bad."
Okay, so what's the fault?
And you won't have an answer. Because the overall level tells you nothing. It doesn't tell you what the fault is, where it is, what component is failing, whether it's electrical or mechanical, how serious it is, or whether the pump even needs to be removed from service. It's like telling a doctor, "My fever is 38 degrees Celsius, which organ is failing?" That's how ridiculous overall level diagnostics are. But industries all over the world still rely on overall levels religiously.
And why can't we use the overall level to determine the state of a machine? It is so quick and convenient.
Here's the truth. An overall vibration level is not a diagnostic measurement. It is a noise measurement. It is the total vibration energy across a frequency band. It tells you nothing about frequency, nothing about phase, nothing about the source, nothing about the mechanism, nothing about severity, nothing about root cause. It's a single number. You could measure the machine with your eyes closed and get the same data quality. Now, let's refer to the chart at the start of this video to walk through the actual fault categories. We'll go through the main fault categories using the summary chart you already saw. Rotor faults such as static unbalance, couple unbalance, dynamic unbalance. So yes, 65% of rotor faults show up early in the overall number. But thermal bow, fluid buildup, eccentricity, these show no early overall rise. So even with unbalance, the simplest fault on Earth, 35% of the faults stay invisible early. (85% of misalignment cases show an early increase in overall vibration. But thermal misalignment, load state misalignment, distorted couplings, these give no early overall rise. Again, the chart shows it clearly. Look at the chart. Only 45% of looseness faults show early rises. 55% show nothing until late. All of them show up early in the spectrum. So overall levels show up with less than half of looseness problems. But although these faults may generate an overall level response, when you measure an overall level response, nothing tells you which faults is responsible. This is the big one, and this is where the chart hits hardest. One of the causes of bearing failures is high vibration levels due to unbalance, misalignment, etc. Bearing do not cause high overall levels. And the chart shows early overall level detection for bearings. 0%. Not low. Not rare. Not sometimes. 0. A defective bearing gives clear spectral peaks, clear envelope analysis signals, clear phase changes, but the overall level stays completely normal until the bearing is almost destroyed. Only late-stage spalling, cage collapse, or total structural failure causes the overall value to jump. That's not diagnostics. That's catching the failure when it's already happening. Wear, pitting, scuffing, lubrication issues, misalignment. All early faults inside gearboxes show nothing in the overall vibration level. Only broken gear teeth produce a large overall spike. The chart says early detection 0 to 10%, late detection 70%, spectral detection 100%. You cannot diagnose gearboxes with an overall number. Electrical faults give harmonic signatures, not broadband increases. Broken rotor bars, stator faults, air gap problems, magnetic pull, eccentricities. These produce no early increase in overall vibration. And the chart shows early overall detection 0%, late only detection 70%, spectral detection 100%. Overall levels are blind to electrical faults. Bent shaft? Yes, overall levels show it. Everything else? Cracks, thermal bow, rubs, coupling wear. Overall level detects almost none of them early. 70% invisible, as the chart shows. But if you see an overall level increase, which fault is it? Who knows? Using the chart. Pumps 45% early, 55% late. Fans 0 to 20% early. Compressors 0% early. Structures 0% early. Process faults 0 to 10% early. All of these faults are only accessible by spectral analysis. You saw the chart at the beginning. You saw the categories. And now I can say this in the video, clearly and brutally. Across all machine types, overall vibration levels detect only about 10 to 15% of early stage faults. Spectral and phase analysis detect 100%. If your plant relies on overall vibration numbers, you are missing 85 to 90% of the faults. While they are still easy, cheap, and safe to fix, you're not running a condition-based maintenance program. You're running a late-stage emergency detection system. You're reacting, not diagnosing. Let me tell you exactly why plants cling to overall levels. They're cheap. They're simple. They require no skill. They create an illusion of understanding. Management loves simple numbers. Nobody has to learn anything. Nobody has to take responsibility. But the real reason? Overall levels hide incompetence. With only one number, You can always pretend the failure was unexpected. It wasn't. You just weren't looking properly. Real diagnostics needs: spectra, phase, time waveform, envelope analysis, resonance checks, cross-channel phase, mechanical understanding. These tools detect what the fault is, where it is, why it's happening, how severe it is, how to fix it, how to stop it from coming back. You cannot do any of this with a single number. If your plant relies on overall vibration levels, you are not doing diagnostics. You are waiting for failures. In the next video, we look in more depth about how plants work with diagnostics departments in reality and the misunderstandings that arise, especially concerning the issue of early and late diagnosis of faults. If you learned something from this, good. Subscribe, make comments. If this made you uncomfortable, even better. If you hated it, excellent. That means you need the next one even more. Stay tuned.